Now, and in order to pursue such a reductionist approach with these motivations that I explained to you, three main questions have to be answered. And they have to be distinguished, because otherwise you don't understand what you are doing. Okay. Now, the very first question, in order to get a reduction going, is this. Does the system really consist only of the identified parts and their interaction and nothing else? This is, so you say, I have a car here, and I gotta know all the parts of the car, right? If I don't know what's under the hood and I only know the wheels, right, and the battery, then you will not be able to diagnose why the car doesn't work anymore, right, or how it works. You gotta know, you gotta be sure that you know you have all the parts, right? And that is called, in the philosophical debates, the ontological reduction. Ontology is the doctrine about being and stuff that exists, right? And therefore it's called that the question is simply, what is there, right? What does the thing consist of? And there the question in economics is, of course, very simple. An economy consists of what? Well, the actors and firms that do buy and sell and produce and so on, right? So it's very clear what's there. And that's called the ontological reduction, which is trivial in the case of economics, but it's not trivial in other cases, and I give you examples. A reduction is clearly impossible if the system is not composed of the identified parts alone. Why is that so? Well, because then you have determinants for the behavior of the system that don't figure in your equation, right? So if you don't know that there's an additional variable for the system, then of course you can't explain the system in terms of the parts if your list of parts is not complete. So for instance, we have in biology in the 18th and 19th century, we have very strong movements. It's called vitalism, and it's now more or less completely dead. And the idea was that in an organism there is, in addition to the physical material ingredients, an immaterial life force at work, the so-called vis vitalis. So that was a long 17th century, also 18th and 19th century. The idea was that living beings are fundamentally different from dead matter, right? They are not just matter, somehow animated, but there is something in addition in them. Vis vitalis, the soul is something similar. In the idea, say, in the Christian tradition, a human being is not just the material, but there is something else in it, the immaterial soul, and it's different from the body. And the idea is then when you die, then the bodily parts, they rest there and decay, and your soul goes somewhere else, wherever they go, right? But of course it is, when you have such a dualistic idea, as you have in vitalism, there is something in addition to the purely material stuff, then of course you cannot understand the whole only in terms of the material stuff, because this is not the only determinants. If the soul is an additional determinant, or the vis vitalis is an additional determinant, you have to take into account if you want to understand the whole. So the whole reductionism only makes sense if you are sure everything, you have all the parts, right? If you don't have all the parts, you forget it, it can't work. So this is quite clear. So this must be, the ontological reduction must be clear, and you must have a good argument for it.
Sorry, I did not understand why the answer to this question is obvious for economics.
Well, there, and by the way, there it seems to be that all economists agree. Well, if you say, what is an economy? I mean, what is an economy? Well, it's all the economic actions that you find in markets, producers and agents. And of course you have external variables, exogenous variables, but an economy is just those people involved in producing goods and in markets and so on. So there is nothing, so to speak, that the wholeness of an economy, there is something in addition, something, he calls it mystical, and it would be mystical somehow. That's the same if you have a car, and the car, it's obvious that the car is just a composition of all its parts, right? And you can decompose it and can re-aggregate it, and then it's the full car. There is nothing over and above the parts, right? And that's the same in the economy. That is a different question. Well, it was a difficult question in biology, but now, as in medicine, if you most Western medicine thinks that we are human beings are just bodies, right? And the complicated stuff and the brain, and that produces then a soul or whatever, or psychological phenomena. But basically, what is dominant today, also in biology, of course, is that a complete materialism, right? There is nothing over and above. We are just composed of these parts. There is not an additional element, right? That the medical profession should take care of. So whether that's true or not is a different story. That's not my point. I'm just explaining what the point is, that if you try to do reduction, you've got to be sure that the system you're considering really consists of the part you have identified and know.
But how, does one decide where to stop, where to not subdivide the parts?
Wait a minute, that's the next thing. Next question, okay. So the first is ontological reduction. That's a precondition for the other questions, right? That's very important. You do not even start a reduction, of understanding and so on, unless you have answered this ontological reduction in the positive, right? You don't start that. If you knew, say, a human being consists of material stuff and of the soul, then you wouldn't try to reduce everything of that human being to the material parts, because they don't determine that they are not determinants for everything. There's the soul in addition, right? And you wouldn't do it. So you only try a reduction if you're sure that the parts are all there. You may still be wrong, but I'm only saying under which conditions you are trying to attempt a reduction. All right, and it's clear in the case of vitalism or with the soul, under these circumstances, the working of the organism can clearly not be fully understood in terms of its physical components. It's obvious, right? Because you are missing one determinant, right? In the case of economics, the case is clear. An economy is made up of the entities at the micro level, consumers and firms, and nothing else. And there Hoover fully agrees, and I wouldn't see how you could argue to the opposite. It's just completely impossible. And the properties and dynamics at the micro level are completely determined by the micro level. So if you ask what determines the behavior of the system, and you know all the parts, then all the dynamics must lie in the parts and their interaction, right? This is this strange term, supervenience. That's the technical term for that, right? If the upper parts are really determined, not the upper parts, sorry, the upper level is determined by the lower level, by the parts, then it says that the system is supervenient on the parts, meaning in physical slang, the system has no degrees of freedom, own degrees of freedom. Everything that the system does can be somehow understood in terms of the parts, right? Or is determined by the parts, all right? And therefore, because that happens, this ontological reduction works for macroeconomics. The question of the micro-reduction of macroeconomics makes sense. The conditions are given. As it makes sense that if your car doesn't work and you bring it to the shop, then they ask which part is it that doesn't function and which we have to replace, right? Under this condition, that works. If there was something whole about the car, then the question which part is it would be, well, one of the questions, but you could also say what part of the wholeness, or what aspect of the wholeness has been broken. Someone drove the car with the wrong karma, and therefore the car reacts to it, right? Because it hates being driven by people with the wrong karma. Whatever the wrong karma is, I'm not a specialist. All right. So this is the first question, it's ontological reduction. It's a presupposition for all other reductionist questions. Now we come to the second question. In order to get the reduction going, what exactly are the parts that I'm considering? This is not just self-understood and obvious. So, for instance, in the case of an organism, and this is what happens in medicine and also in biology, all the time, what parts am I zeroing in? Organs and bones, cells, molecules, atoms, elementary particles. So a decomposition of something which is not an artifact, an organism, a decomposition into parts is far from unique. It's absolutely not clear what simply are the parts of an organism, right? This is a completely unclear question. It's a fairly clear question when you have a bicycle or a car, usually, although some things may be so integrated that you don't know which is a part. Can I take them apart when they, put together in a way that you can't take them apart anymore? But in many cases, say, if you take a Lego castle, then it's very clear what the parts are. It's just one way, right? Unless you move in a temperature zone of 400 degrees, then your parts of your Lego castle won't be identifiable because there aren't any parts anymore, right? So the question of identifying parts is non-trivial, right? Absolutely non-trivial. In case of organism, it really depends on the question. So what one typically does in reductionist questions, so if you look at physics and chemistry and stuff like that, one proceeds stepwise because it's impossible to jump from the system level to the level of the smallest parts. Therefore, this question that Hoover sometimes asks, shall I understand macroeconomics in terms of atoms? It just doesn't make sense. Nobody would ever ask this question, right? Of course you do, you go one level down, as you say, I understand an organism, so if you go to the doctor in the hospital, well, it may be one molecule for some diseases, but very often you will say, which organs is it, right? So the doctor, she will look at which organs are probably the culprit, right? It may be then that it's one molecule that does it, that does something stupid, so you have not enough sugar, whatever it is, right? But usually you go just one step down and not to the and you are not even interested in going to the molecular level or atomic level. So one proceeds stepwise because it's impossible to jump from the system level to the level of smallest parts, and therefore what I mentioned from Hoover, this decomposition of the macroeconomics and disaggregation, that sounds very, very plausible, right? If you want to go down to a lower level, then decompose in larger units. So for instance, then decompose investions in different types of investions, right? If they had different causal effects. That makes sense in a way to a reduction. How far you want to go is a different question again. So that is in many sciences, this is a reasonable procedure stepwise, because it's impossible to jump from the system level to the level of smallest parts, and it may not be interesting to go to the smallest parts, right? If you know that someone has a disease, and then you know, look, there is something wrong with this organ X, and that organ needs this and that, then it's not fruitful to analyze that possibly in terms of molecules. It's enough when you say, okay, yeah, for instance, you have problems with your knee, and then your doctor says, look, you've got to exercise a little. Okay, you really, why don't you practice a little with your knee, right? Then you don't need the molecules that do all the stuff in your knee. It tells you, yeah, it's your knee, and you've got to practice, right? So it doesn't make sense to go further down. So, for example, here that one goes stepwise, understand the organism in terms of its organs, understand the organs in terms of their cells, understand the cells in terms of their constituents, there are different constituents of cells, understand the constituents of cells in terms of molecules, etc. And this is what happens in real science. You go stepwise, right? Sometimes you go several steps at the same time, sometimes not. So it's very different, depends on the situation, right? And the reductionist impulse is always the same. I understand a certain system in terms of its constituents, and what the constituents are, I have to decide, right? It's not always obvious. Okay. And this seems to be, I mentioned that already, similar to the approach of Klein and Tinbergen, obtain model more and more disaggregated data, and the complete disintegration would be individuals, but you could understand in this way, parts of the upper level in terms of units from lower levels. So the identification, that's exactly the answer to your question. How do I identify the parts? This is partly conventional. It depends on the situation. Nature doesn't decompose naturally in parts, right? In many cases, it doesn't do that. If you look at quantum mechanics and stuff, it's really very hard whether there even parts exist. It's not clear that there are parts, right? Parts are something where I can say, okay, if you take this one, this has several parts, there are the pages in there, you can take them out, and it's obvious there. But that is not the situation that is in nature always given. And even with artifacts, it's not always given, right? So the question is, what are the parts? Has to be answered, and it may be complicated, right? Okay. And then The third question, if you do reduction, is in order to get the reduction practically going, whether there are, so to speak, natural steps in terms of greater subunits. Is it possible to make intermediate steps on the way to the reduction one is interested in? So if you are interested in the reduction of the macroeconomics to microeconomics, then you've got to ask the question, wait a minute, aren't there interesting steps in between? Because this is a very, very, very large distance, right, from macroeconomics to the individual actors. So it may be useful to make intermediate steps to get that practically going. And you have that in physics and biology, and you have that everywhere. You make intermediate steps, and you've got to be inventive, right, to find out what a good intermediate step would be. These intermediate steps typically involve all sorts of idealization, approximations, and other counterfactual assumptions. This is where science becomes really creative. You got to think, what could I do, to break this complicated system up into some sorts of subunits who do then the job of providing understanding of the system. And you got to analyze it and have to know something about the system. And all sorts of things are happening there, and you got to be creative, and people will disagree whether it's good or whether it's bad, and you have all things that make science so exciting. So, for example, according to Hoover, for the reduction of macroeconomics to microeconomics, he thinks describes the economy by a representative agent model that is the first step toward a detailed microfoundational model. So, this is how Hoover sees it, right? May work, may not work, don't know. Well, if I compare with other cases from other sciences, a representation of the system in the same way as the parts may be extremely implausible, right? What you do is you assimilate the descriptions, but in fact, the things are very, very different. So that may lead you into the wrong direction. Although it looks a little like, I'm assimilating that may make the reduction easier. Yeah, it's not clear. In some cases, it's extremely implausible. So I said that already in thermodynamics. If you imagine a gas is something like a big molecule, you can never model the approach to equilibrium. But this is all you're interested in. Not all, but this is very important in what you're interested if you look at thermodynamics, right? So if you have the same, of course, in markets, if you have the macroeconomic variables and the competition between individuals is eliminated, so how you have a price mechanism, between supply and demand? Yeah, doesn't exist. So if you represent a gas by a giant molecule, all properties you are interested in have disappeared, approach to equilibrium, temperature, pressure, etc. And Hoover sees that, right? He's aware of that. And that's right. Therefore, looked at from the outside, whether this representative agent models, whether they are really a way to reduction, whoops, that is critical. Perhaps not. Similar in macroeconomic representative agent, coordination problems among the same kind of economic actors cannot even be articulated. Right? You do not have that in the model, and I really did this very famous article by Kerman, I mentioned him here, articulates that, and he criticizes these macroeconomic representative agent models, unemployment, for instance, no trade takes place, etc., etc. Still, I'm saying that probably in the next slide, still, you never know what even the weirdest model can produce, right? So it's always, in science, it's very difficult to say. One should not prematurely dismiss crazy steps in attempts to reduction because they may turn out to be heuristically fruitful in unanticipated ways. And you may even say, okay, I thought I'm using that for a reduction, this model, right? For instance, representative agent model. But then I discover, wait, they have another application that's very interesting, right? So I use it for something else. So this is in the creative process of the sciences. There are many crazy steps, and some people are then, immensely successful because they don't dismiss something that looks not promising, and they find something out, and therefore one should be very, very careful here. Very often scientists disagree about the heuristic value of research programs, but that's not so interesting because in the end only success decides. There are no typically hard arguments in all the sciences about heuristic programs. So someone says, yeah, I'm following this route here. And I says, no, that won't work. And says, no, I'm following this one. There is typically not so much discussion about that because everyone knows in the end it'll be success, right? And if you're successful, fine, then you've won. And if I'm successless. But you cannot really decide that at the level of heuristic discussion. So it's very hard to say, well, how far will these representative agent models lead? Well, you may say, yeah, there are probably some limits here and there, but whether they lead there and how helpful they will be concerning reduction, well, this is heuristics and it's very hard to decide. If you work it out, if you work out the research programs, then you will see where they lead and how good they are. And that's the level where the discussion should be taking place. Therefore, extended discussion about the possible success of research programs is of limited value. That is the case, and that you see also in other disciplines, right? And therefore, the question whether this, how useful these representative agent models are concerning reduction shouldn't be discussed abstractly. Okay, now let's go to Hoover's reduction possibilities. I mentioned them in the beginning of his paper. He has these three reduction possibilities, and they are really confusing. And I think they are a little confused. So Hoover distinguishes three what he calls possibilities of the dependence relationship for reductionism and the scientific interest in establishing it: elimination, ontology, and explanation. And that seems to me a completely heterogeneous list. So when Hoover speaks that reduction may lead to elimination, right? When he thinks that macroeconomics is reduced to macroeconomics, macroeconomics is, when it's radically reduced, is eliminated. Now, first of all, elimination is a possible consequence of reduction. It's a possible consequence after a successful full reduction of the system level to the component level regarding all concepts, methods, and explanation types. If you look at that you really eliminate these cases in the history of science, that's a very complicated process, and very rarely are really things then eliminated from the upper level. Then he speaks about ontological reduction. That's a presupposition of all the other questions. So that's on a completely different level. So we have the reductions, right? One is a presupposition, namely ontological reduction. The other, elimination, is a consequence of reduction. So it's on very different levels. And then the explanatory reduction is a special type of reduction that's logically independent of elimination. So what he's mistaken here, or that list is so heterogeneous, because the reduction possibilities he's speaking about come from very different levels, right? And to put them in one list is completely confusing. So you've got to understand what are the motives and the presuppositions for reduction, what are then reduction goals, namely, for instance, explanation, understanding of limitations, understanding of regularities, and then is a next question, consequences, namely possibly elimination or not elimination. And one should distinguish these levels, and then you can understand what the questions are. And I think this is not optimal in Hoover's article. Okay, it's a very heterogeneous list. Now,